What's up guys? So in a previous video we showed you a pretty complex part that we programmed using CAM Assist from CloudNC. Now in today's video I'm going to take you through the entire process of what we did to program this part using CAM Assist. Now guys, I'm going to be completely transparent with you today and show you the tips and tricks that I've learned along the way in order to get a good output from CAM Assist. You even may notice that the toolpaths that I show you here today differ from the ones that we had in that video from last week. And I'm going to show you exactly why towards the end of this video. So let's get right into it. Now guys, you can see that I already got the part file open, but before we get started, there's a few things that we need to talk about in order to make CAM Assist successful. There's three major things that you need to do. Number one is to set up your part file correctly. Number two is to create a robust, very detailed tool database, which we spoke about in our previous video. And number three is to give CAM Assist a very good solid model. Now that is the part that we're going to get into a little bit later in the video. So first, let's look at setting up the file. Now you can see here I've already brought in my vices. I've went ahead and created some stock, which is optional. And I've also made some collision avoidance. And we'll talk about that when we go to set up our CAM Assist toolpath. Now for now, I'm just going to turn that off. And what we need to do is we need to open up our file. And here on our second tab, our master model. We need to select our part file that we're going to cut. Now I've already got this in here, that's why it's yelling at me. But this is what's going to tell CAM Assist what we're going to cut. So once we select that, we'll move on to our stock. Now you can see I've already created the stock file here, or stock model. And next we're going to go to our fixtures. Now I'm going to delete all of this. For fixtures, you only want to select what is relevant. You don't want to bring in a ton of models in here because that's going to really slow down your calculation. So what I'm going to do is I'm just going to select my jaws and maybe the body of this vise. Now these are very simple models. There's not a whole lot to it. Now a lot of times what may happen is you download a vise from somebody's website and it may come in with hundreds of solid bodies. Now what you want to do is go in and simplify that as much as possible because all of those solids are going to slow down your calculation. So in this case, I've only selected what we need to make sure that CAM Assist can see that and use it as its collision avoidance. So I'm just going to hit OK now that we've set that up. That's going to be really all you need to do to set up your file correctly for CAM Assist. And that's going to give it the basics of what it's going to cut, what to avoid, and what stock to use when you're going through its calculation. Now, if we want to set up an Op2 for this, now you can see I've only got Op1 set up, and that's just for time purposes. But if we want to set up to cut Op2, what we'll also want to do is bring in our fixture, place it where it needs to be, and we also want to create another machine group. So it does need to be separated by machine groups for every operation that you're going to do. So in that machine group, we will select the same part model as our master model. We'll select the same stock. So that is one thing that you need to know, that if this was a part that we need to get to all 6 sides, and we're doing it in 6 operations on a 3-axis machine, then you will need to create 6 different machine groups, but the stock will all be that same stock that you use in the first machine group. Now, it's not going to calculate from that. It will calculate from the stock models it creates from each machine group. But in order for it to calculate properly, it needs that same stock that you use in the first machine group. Other than that, you will create your vices or your fixturing relevant to each machine or each different operation. But for time purposes, we're only going to be machining this first op. So this is all that I have set up. Now the last thing I've done here is I've created a collision avoidance model. So CAM Assist needs things like this in order to tell it where to stay away from, if there's anything you want to stay away from. Now in this case, what I'm doing is I'm creating this model that's 2.5 inches deep, and I've also created these little boundaries to tell it to stay away from these pockets. Now I'm only going to use this collision avoidance model for this first operation. And what I'm saying here is I'm forcing Cam Assist not to look at anything below this 2.5 inch depth, and I'm also forcing it not to try to cut these pockets from this operation. And what I'll do is in my second operation, if I was to run that, I would not select this collision avoidance. So what it's going to do when it flips over, it will see that it has not cut these pockets from that first op, and it needs to cut it from the second operation. But for this one, I know that I don't want to try to cut these from this first op because they're so close to this wall. So that is why I've created this collision avoidance model to force it not to try to cut that. You may notice that I actually created a model for this. This is a solid model, and that's because Cam Assist doesn't really look at surfaces. So I can't just create surfaces for this. I need to create a solid model. So now that that is created, I'm just going to jump into CloudNC's Cam Assist. So when you download that, you've got a little tab here for CloudNC, and I'm going to go ahead and click Cam Assist. Now it's warning me that this file is going to be saved if I run this, so I'm going to hit yes. Now once that opens up, you'll first see your tool libraries. Now what I'm going to do is I'm just going to use the Cam Assist tool library that they give you whenever you download Cam Assist. So it's really robust, it's got a lot of tools in it, and that's going to make this calculation much better than my current tool list. So we're going to go ahead and use that. Now you can see it's pulling from my machine that I've got selected, the machine that we're using. Now our machining mode, currently you have 3-axis or 3+2. Now technically what I'm using right now is a 5-axis machine, but we don't really need 3+2 in order to get all the sides of this part. It's really a 3-axis part. So I'm just going to leave it on 3-axis. Now you can see it will pop up with any machine group that you have created. Now in this case I only have one machine group created, so that's all that I see. If I have a second machine group that I would use for op 2 on this, you would see that down here. Now I can select or deselect that if I want and only calculate one or the other. For this exercise we're only doing op 1. You want to make sure that you have your plane selected properly. So in this case I've created G54 as my work plane, or my WCS. And here is where you have your avoidance geometries, you know, where you want to stay away from. So when I click that, I can click that avoidance geometry that I created and hit enter. And you'll see it populate here with the number of geometries that you have selected. Now the last thing on this page is your work holding security. Now what I'm doing is I'm telling it how well I'm holding this part, from very poor work holding to excellent work holding. Now this is going to come into play if you are using Cam Assist physics-based feeds and speeds. I'm going to tell it to use the feeds and speeds that I have in my cut parameters and only use the physics-based software if I don't have those cutting parameters selected. We'll see that in just a second. But it's going to adjust those cutting parameters based off your work holding here. Now I'm just going to tell it excellent for now, and we'll go to our next tab for tool use. Now here I can see the tool library that I have selected. I can see the material, so we're going to be cutting this in aluminum, and I can even further break that down to the type of material. Now I'm just going to leave it as generic. And for my cutting parameters, you can see right here we have a few selections. If I select this, it's only going to use the feeds and speeds that I have saved in my tool library in my cutting parameters. Now if I choose the middle one, which is what I normally choose most of the time, it's going to use those cutting parameters in my tool library, but if they are not specified, that is where it's going to select from CloudNC's cutting parameters using the physics-based algorithm. The last selection we have is just that. It's going to look at the physics-based software by itself. Now, I can adjust here if I want to be more aggressive or more conservative. But for this, I'm just going to select to use it from our cutting library. The next thing you can see is all of the tools that we have in this tool library. Now you can see there's a pretty good number of tools here. Now I can filter tools by deselecting them if I know that I don't want to use certain tools for this process and I don't want it to be considered in the calculation. Another thing we can do here is if you want to limit certain strategies for certain tools, say you only have a roughing tool in, maybe it's like a tool that has chip splitters and you don't want to finish with that tool, or maybe you don't want a helical bore with certain tools. I can filter that right here. So say this tool is only a finishing tool, I can turn off the roughing. Vice versa, I can turn off flat finishing and I can turn off wall finishing and only use this tool for roughing. So that's another way that we can filter with our tool database here. So really that's the only things that we have to look at with this page. Next, if we go to the Advanced tab, now here's where I can start filtering the type of operations that I want to choose on this part. So for instance, most of this face, this top is going to be gone and I'm only going to be left with this rim. So maybe I don't want to face mill this. Maybe that's just a wasted operation. So what I could do is I could turn face milling off and it will then filter that out and not use that as its calculation, or not use it for its calculation. Same with tapping or spot drilling. You know, if I'm using only high-speed drills here and not using carbide, maybe I want to make sure that I have spot drilling turned on. Or if I'm using carbide drills and I don't want a spot drill, I can just turn it off, which is typically what I do. Next we come down and we see this machine full part. So I have it selected, but if I deselect that, I can select the faces that I only want to machine. Maybe I'm only trying to machine a certain section of the part. I can go in and filter that and only select those faces that I want it to. Next is the generic stock values that you want to leave for both axial and radial. Now, I'm not really a big fan that this is a hard value right now, so you can see it's set to basically 10 thousandths on axial and radial. I'm not really a fan of that because that may be different. You may want to leave different stock amounts depending on your tool size. So in the future, I personally would like to see this change to maybe a percentage, like maybe only leave 3% of the tools that you're using. So, and maybe that could even be further to, I don't know, something like 3% of the tool not to exceed 10 thousandths or something like that. It's a hard value of 10 thousandths or whatever you want to say. I can say maybe only leave 5 thousandths on the floor and 10 thousandths on the walls. Whatever you want to do right there. Next is some strategies that maybe you like to use that you can change here, like far as how you want this to be ordered. You know, what type of finishing you want to use. Do you want to use 2D area mill? Do you want to use more of a horizontal tool path? One big one here is for finishing maybe walls and stuff. Do you want to use waterline or do you want to use something like a hybrid tool path? And then for chamfering, do you want to use a chamfer mill or do you want to use a ball mill to chamfer with? You know, you can set those parameters here. Next we look down and we see, do you want to consider undercuts or not? Now you can see with this collision avoidance geometry that I've created, I've got 2 holes going through this part. Now I made those bigger than the hole that's in the part right now. So if we look on the bottom side of this, you can see I've got some material left of the part in between the diameter of this collision avoidance and the part itself. Now what Cam Assist is going to see this as an undercut. So if I left this checked, if I have a tool that can reach down in here and try to undercut this, it's going to try to do that. Well, I don't really want it to do that, and I don't have any undercuts on this part anywhere else, so I'm just going to uncheck that. Now, if I did have undercuts that I do want to cut, and I don't want it to try to do that here, What I would do then is I would create my collision avoidance model with this same size hole right here. I want it to cut this hole, but I would create it as the same size of that hole. And then it would see that there's not an undercut there. Next, we got our toolpath generation. You know, do you want to, once Cam Assist puts all the toolpath down that it finds, do you want Mastercam to go ahead and calculate that toolpath, or do you want to just leave it dirty? For this case, I'm just going to tell it never. You know, just for time purposes, I typically tell it to go ahead and regenerate. But for right now, I don't want it to generate. The last thing is this next generation roughing strategy, or their legacy roughing strategy. Now, as Cam Assist evolves, they're obviously going to put more cutting strategies inside it using this toolpath that Mastercam has. So it's important to note, as the time of this recording, not every strategy that Mastercam has is incorporated into Cam Assist. So if you're seeing it using some strategies that maybe you wouldn't use, that you would use differently, it may just be that Cam Assist has not incorporated it yet. So one of those things being dynamic milling, it actually does have it now, but it didn't in the beginning. So with this next gen roughing, it's actually going to use the OptiRough, the 3D dynamic strategies that it did not have before. So I'm going to leave that and always use next gen roughing. So that is the last parameter that we need to set. Now I'm ready to just hit OK and let this start calculating. Now, since this is a pretty feature-rich part, it's going to take a pretty good while for Mastercam to calculate these toolpaths. So I'm not going to hit OK right now. It's going to take probably an hour and a half to generate all these toolpaths. So just know that right now is when I would hit OK and it would start generating. Now, I've already got this done. So if we look at this one, this is what you would get once Cam Assist has finished on this part. So let's start going through this now. As you can see, I've got 123 toolpaths here. And if I start, I did use face milling. So as you can see, it starts out by face milling and then it gets into roughing. Cam Assist is going to follow a very specific order of operations. It's going to face mill, it's going to rough, it's going to flat finish, it's going to wall finish, and so forth. You know, then it's going to do hole making. I spoke about this a little bit in that previous video. And here's where, you know, Cam Assist is going to get you 70–80% of the way, and you as a skilled programmer are going to have to come back in, check out all these toolpaths, make sure that they're right with what you want, and maybe rearrange some things, fix some things that it didn't get. And that's that last 20% that you need to do as a skilled programmer. I'm actually just going to take this and select all my toolpaths and come up here and let's just run verify to see what this gave us. Now when I get this up here, I'm just going to cut some of this stuff off that gets in the way. And let's slow this down just a little bit. Let's just start simulating this. Now you may see that some of this is a little bit inefficient, and that's where we can go in and start playing with it a little bit and get it a little bit more efficient and better to what we like to see. And it even may selected some of the tools that you may not use, and again, that's going to go back to your tool library. And it's going to look at all the iterations that it can do and go through so many different processes to find what it thinks that the best method to use is. Now, in real life, that may be true and it may not be, but that is for us to decide in that last 20% that we've got to do. But again, I used the Cam Assist tool library here, so I don't know what all tools they have set up. Maybe they're missing some that I would actually use. Maybe they've added some that I wouldn't or that I don't have. So this is where it's important for you to build your own tool library with the tools that you use every day. Now, one thing that might be beneficial, because it does take some time to build that out, right? And especially to add your cutting parameters that you use. So one thing that you could actually do to get you going faster is maybe use CamAssist tool library that they give you, because it has so many tools, to get maybe a more complete program, and then go in and just switch the tools out with the tools that you use and the cutting parameters that you like. Now that is adding a little bit more time than you will get to, or maybe that's adding a little bit more time to your programming than you would like, but that's going to be mitigated over time as you build out your tool library. Now we can see here this has gotten a good bit of the part, and maybe there's some regions that it doesn't really get, but I'm not really seeing any gouges here, and we'll do a compare on this when it's done to really see what all it's gotten. But this is pretty impressive for, you know, hour and a half to 2 hours, let's say, that it took to actually calculate this. I can't program this part that fast. You know, this, just looking at this part, this has got a lot of clicks, a lot of geometry that you're gonna have to go in and select, you know, for machining geometry, avoidance geometry. There's just a lot of clicks that you're gonna have to do with this part. But you can even see here how it's leaving stock right here along those pockets, and how it did not cut into those pockets, because it's seen that with that collision avoidance geometry that I selected, and it made sure that it did not try to machine those features. Same with the outside, I'm limited to that 2.5 inch depth with that collision avoidance model, so it's not going past that. Some of this is taking a little bit to calculate, and that's because of those fillets that it's trying to machine. But it's pretty impressive with how much it's been able to machine. All right, so that's our last tool. That's our chamfer tool. Let me come here and let me turn my tool off so we can see this better. What I'm actually going to do is I'm going to come over to my compare. It's already up, actually. Let me hit that. Start comparing this model. Now you can see everything that is green is machined to size, and this blue here is where it has not machined, or it's leaving some stock. So I can see, okay, it didn't get all the way around right here. Maybe it didn't select this inside of here, same right here. So really it machined nearly everything on this model except for some of the fillets at the bottom. Now it did leave some material out here on this outside, and I'll tell you why in here in just a second, but for the most part, CamAssist was able to see most of this part and was able to machine that complete. Now that's pretty impressive. So what I'm going to do now, I'm just going to minimize this and come in to see some of these parts that it wasn't able to reach. One of those things is I know that it's finished some of this fillet, but it didn't get all the way around. So now what I can do, I can come down, it's probably this freeform. Yeah, so I can see that it's only selecting to there. Now if I just find that operation here, if I open that up, come here to model geometry, I can see that it's only selected the fillet right here. Now what I can do is I can just tell it, hey, I want you to cut these features as well. Hit OK. Now I'm just going to increase this step over a little bit just so it doesn't take so long to calculate. Let's regen that. Now you should see it cut that fillet all the way around. Now again guys, this is part of that 20 to 30% that you're going to need to do to go through this to make sure that you're machining what you want to machine. We'll wait till that gets done calculating. But really all I would need to do is, if I'm satisfied with how it's machining this, if I'm satisfied with the cutting parameters for the fillets on the inside, I would do that same thing. I would go through and select those fillets that it did not select in order to get a more complete tool path. All right, so there's our newly calculated tool path. As you can see, I increased the step over just so it wouldn't take so long to calculate. But now we're going all the way around here. So like I said, with the parts that it missed on this inside, you know, I know it missed these fillets here and it stopped somewhere right in here. I would do the same thing. It's more than likely I would need to go in, yeah, right there. I would just come in here under my model geometry and select these fillets that it did not recognize. So for time's sake, we won't go through that, but you can kind of see how that works. Now this one is drilling all the holes at the top, drilling all of these holes. Now as you can see, it's just a straight drilling operation. It did not do any spot drilling because I told it not to. Now one of the limitations with Cam Assist at this moment is that it doesn't understand the difference between high speed and carbide tools, so I don't believe it's going to use any peck drilling. Anytime it sees a hole, it's just going to use maybe like a G81, drill all the way to the bottom and come out. So if you're using high-speed steel drills, that is something you want to check on and make sure that you go in and change it to a peck drilling cycle if you want to do that. We could dissect this entire program and go through it line by line and see, you know, well, I wouldn't really do that, or maybe I would do this different. But for the sake of this tutorial, I guess you could call it, I'm not going to do that because, again, guys, I used Cam Assist tool library, so how they set their cutting parameters up is probably not going to be how I do it or how you do it. You know, give a part to 10 different machinists, you're going to get 10 different parts or 10 different ways that that machinist got to that endpoint. So for that reason, we're not really going to dive super deep into every single tool path here. So that's really going to boil down to how you set up your tool library. And we'll look at that in just a second. But one thing I do want to show you is, like we noticed in the beginning when we started roughing this part, personally, I probably wouldn't helical mill from the top of this part. I would probably come in with a large drill and pre-drill some of this out. And as you can see here, it's roughing from the outside for these outside open areas, but on this inside you can notice that we're helical milling from the top in several of these pockets. That's a waste of time and it's going to be hard on our tool. So what I've done, and this is the part of that 20% I was talking about, what you might want to do, if I turn this layer here on, just going to get rid of some of this, make this a little cleaner to look at. Now what I've done is I've created these three curves here. I look right down on the part. Two of these curves is right inside these pockets. One is right here on this outside. Now what I might do here is I'm just going to come up under the facing toolpath here and I might create a drilling operation. Now I'm going to come to my tool library and I'm going to add, I got a 40mm drill here that I'm going to add. Now I can come in and create a drilling operation and I'm going to select these three holes or these three curves. I'm just going to quickly click that drill. I'm not going to worry with setting feeds and speeds here. That's not really the point. But I'm just going to come here, select my top of my stock and where I want to drill down to. Maybe I want to drill down to this floor. 940. I might add a little bit of stock there. I don't want to go all the way down to the finished size. So I'm just going to hit OK on that. Just to quickly throw a toolpath on there. You know, hey, I want to come in with this drill, pre-drill this. Now what I can do is I can add that to my stock model. Now this is going to cause everything to go dirty below here, all my roughing operations, but we'll at least calculate this first roughing operation so you can see the difference here. So I'm going to regen that stock model. Now you can see my holes are added. Now if I come here and regen this first roughing operation, we'll now see that it's not going to helical mill from the top in these three areas because that material's already removed. That's going to be easier on my tool. It's going to be a lot faster ultimately a better process. Now currently, at the time of this recording, ChemAssist doesn't see this as a strategy. Now I've talked to them a couple times about this because I've seen this, I've used this in other models that I've sent to ChemAssist. What I would typically do here is this exact strategy where I would come in and pre-drill it with a larger drill, then come in and rough it out with an end mill. Now, like I said, at the time of this recording, ChemAssist does not consider this as a machining strategy. They are considering adding it after our conversations, and because, you know, it's much more efficient and it's easier on the tool. So just know that this is part of that 20% that you're going to have to do if you want to use this as a strategy. So now I can see it's not helical milling from the top in either one of these holes as well as this outside. I'm only helical milling down to this bottom, to that floor inside of those separated pockets. Likewise, I can do that same with these holes. I could come in and drill those out, but you can see it's helical milling those because it did not find a drill to drill that out. Now, what I was saying before, it doesn't use this as a strategy. So right now, the only thing ChemAssist is going to do with drilling operations is it's going to match a hole to a drill that it has in the tool library. So it will only use a drill if that hole matches the diameter of a drill that's in the tool library. So I can see this is going to be much more efficient than what it had before. Now all I would have to do is go in and recalculate these tool paths. So now let's get into some of the cut parameters. I want to quickly show you guys what I mean by setting up your cut parameters in Mastercam. Now you can see here, we'll turn some of this geometry off so you can see it. You can see the step over and step down that ChemAssist is using for this tool. You can see that's a pretty large step over. Now I don't know what they're using as their cut parameters, but I can go ahead and tell you what I use more than anything is more of a dynamic strategy, especially for a tool like this. Let's look, that's a 3/4 inch end mill. With my cutting parameters, I'm going to get a different output than what they did here, and I'll show you that in just a second. So if I open up Mastercam's tool manager, when we showed you two of the parts that we had programmed, or two of the different files that we programmed in that last video, one screen we had ChemAssist output, and the other screen we had an output that we used this tool library as. We talked about a little bit of how we limited the tools. We only had 9 tools in that tool library. And again, that's not good for ChemAssist. It wants a more robust tool library so it can create better output. But what I want to show you guys is in that tool library, I added just 2 different cutting parameters. And that's why you've seen the roughing strategy as a different output from the 2 different screens. So when you normally create a tool, for instance, I'll go in here, and if I open up this tool, when you typically create a new tool in Mastercam, you'll give it the parameters for the tool itself, and then you'll come over here and you may or may not spend the time to fill this out here as far as surface footage, feed per tooth, the number of flutes the tool has, and so forth. You can even tell it the roughing and finishing step over percentages that you want to use here. And if you save that to a tool library, anytime you create a tool path and you click the tool, by default it will bring in the parameters that you set here. It's very important to note that in the past, this is all that I have ever done, and probably most of you have ever done, is set these parameters. But ChemAssist is not looking at those parameters, okay? It does not take those parameters into account when I was talking about cutting parameters. Now, this is my 3/4 inch Core 5 that I used in that video, and it's not going to use any of those parameters that I set. What it's going to use is this tab here, this cutting parameters. Now when you double click this, it's going to bring you to this page. Now you can see I only have 2 cutting parameters set in here. Now whenever you create a tool library, this is going to be blank. No matter if you set all of the tools parameters pertaining to that tool like I just showed you or not, it's not going to be here in this cutting parameters. What you're going to have to do is go in and set your cutting parameters based off the type of strategy that you're using. Now for instance, so I've created this one, and you can see here that I've selected aluminum, and it is for shoulder milling. Now here's all the different operation types that you can set cutting parameters for. So I've selected shoulder milling, and now I go through and I set what feed per tooth I want to run, what finish axial and radial I want to do, and what roughing axial and radial depth of cut do I want to use. And lastly, I set it for a certain diameter of tool. Now here you can see I have 740 to 760. So what it's going to do is anytime it sees a tool within that range, it's going to use these cutting parameters. For instance, a roughing radial step over of 75 thou, an axial step over for roughing at 2 1/4, and so forth. My surface footage at 1963, and a feed per tooth at 33 thou. Now that's going to be 500 inches a minute for a 3/4 inch tool, for a 3 flute tool, or for a 5 flute tool, sorry. So what I'm doing here is I'm trying to limit this to that 3/4 inch tool that I typically use for roughing, which is that Core 5 for aluminum. So once I save that, now that is saved as a cutting parameter for that size tool. Now as you can see, I also have face milling in here, and I've set some parameters for it. So in that last video, when you see the roughing strategies are different between those 2 files, that's because of this strategy here. But I really wanted to show you guys this because I don't want you to get confused by what I mean by when I say you need to set your cutting parameters inside of Mastercam. Because you may think you're setting it with the tool and then it's not using it, and you may be confused why. Now that this file is open, let me bring that over here. Now you see I get a slight different output than what I just went through because I had different tools set in this tool library. But the main thing I want to show you is on this roughing strategy, you can see it's using that 3/4 inch tool. But now if you'll notice, my roughing pass is completely different. And that's because it's using those cutting parameters that I just showed you. Whereas if I go back to this page, look at the difference in the cutting, the step over and all that you're getting. That is what I mean by spending the time to set up your tool library properly in order to get the best output that you want to see from Cam Assist. We could spend hours talking about this, we could spend hours going through this, but we'll save that for another time. You're kind of getting the understanding of why I stress your tool library so much. All right, let me get this file that you've seen up on the screen in that last video. Because like I told you, you might notice some differences in the tool path from that video to this video. They're actually much, much better in this video. And that's because I sent that file to Jay back at CloudNC, and he really gave me some very good pointers on how to get an even better output from Cam Assist. So I want to relay that to you guys. All right, so now that's calculated, and you can see I've got a much better output. It's not gouging into my wall. And that wasn't that hard of a change to do. But when I sent this to Jay over at CloudNC, he was actually very alarmed that it actually gouged the part, because he said typically if you've got a good model and a good setup, CloudNC will not gouge your part. It's actually very hard to make it gouge. So the fact that it was doing that was pretty alarming. So I've got the one that we've done today opened up so you can see as reference. So right there's the finishing that it got today without any input. I did not go in and change this. So I can see there that that's a much better output and it's not gouging into the walls. And like I said, it's not picking up the holes. Now, there's a lot more areas that was very similar to this. It just did not give a good output. That is because the model itself was not very good. So it was an older model and it was a typical file that you might get a step model. Now normally when you bring a step model into a CAM software, what you'll get is a lot of split faces. Now you can see inside this hole right here how these two faces are split, and it's really apparent inside of pretty much all holes. You can see all of these holes have split faces. And that's pretty typical with step files. I see this a lot. Now, to you and me, we know by looking at this model that that is a hole and it's intended to be a hole and we may want to drill it. But CloudNC doesn't know to interpret it that way. So when it sees those split faces, it's not seeing it as a hole. And it may see all these redundant faces and not really know what to do with that. Same with this fillet. Now what was happening down here, now I can't see this, but there might be a little mismatch there from the interpretation that the CAM software did on this step file. So it wasn't seeing this as a wall and it did not know to stop right there. So that's why it was gouging into our face. So this is where you need to spend a little time in giving CAM Assist a very good model to begin with, because you might get the same output that I got here where it's gouging into your faces, it's not recognizing your drilled holes, things like that, because the model itself is just not that good. So what we did here, if I zoom into this, now you can see this is a solid face going all the way around in those holes. What we actually ended up doing is deleting all of the fillets around this bottom, and even some of these wall fillets on the inside of this pocket. We ended up deleting those and recreating them in order for Mastercam to recognize that a little bit better, or CAM Assist to recognize it. So once we did that, we got a much better output. Now I can go through a little bit of that for you because Mastercam has some pretty cool features here. Now if I go to my model prep, I can see this drop down here for Simplify Solid. Now immediately if I select that and I just select this entire model and hit OK, I can see that there's 98 simplifications that it can make. So when I hit OK, there's 593 redundant faces that it removed. So when I hit OK to that, it's going to take a second to calculate. That's probably because I already have toolpath generated on this, so it's not going to like me doing that. All right, so once that's done, you can see all of my toolpaths went dirty. Probably should have created a copy of this model before I did that, so let's go ahead and do that now. But what you can see after we ran that is now that got rid of all of those split faces. And even inside the holes, you know, so that cleaned up the model really well. The next thing we can do is go to Optimize under that same tab. So again, I'm going to select the model. 1,219 optimizations were made. From there, we could probably try this like it is. I think we'll still get some issues with these fillets. If I remember correctly, I was still seeing some problems with there, and that's why we went in and actually deleted all of the fillets themselves and recreated them. But if I go to Repair Small Faces, Yeah, I'm not really getting any repairs that need to be made, but that is one way of getting a better model to use with Cam Assist. Now guys, I know I threw a lot at you today, and I really want to make sure that you understand these three main principles when you're using Cam Assist. That is setting up your file correctly, that is bringing your fixtures in, setting your collision avoidance, all of that. You want to make sure that your tool database is robust and you set up your cutting parameters the way you like. And three, give Cam Assist a very good model. Now you do that and I guarantee that you will get very good results out of Cam Assist. Now guys, do not sleep on this technology. I strongly urge you to check this out, see if it's good for your application, the things that you do in your shop, because I'm telling you, this is the future. This thing is only going to get better. Guys, if you like this video, please hit that like button. Go ahead and subscribe if you want to see more content like this as we roll it out in the future. We'll see y'all next time.